Long before rapamycin or NAD supplements, scientists knew one intervention that reliably extended life in the lab: simply eating less. Caloric restriction is the oldest and most robust anti-aging finding there is, and fasting is its trendy modern cousin. But the story in humans is more nuanced than the influencers suggest. Let's look at what eating less actually does, and doesn't, do. Let's start with just how old and solid this finding is. All the way back in the 1930s, researchers discovered something remarkable: if you feed lab animals significantly fewer calories, typically 20 to 40% less than normal, while still giving them all the vitamins and nutrients they need, so they're undernourished in calories but not malnourished, they live dramatically longer. And not just longer, but healthier, with less cancer and less age-related disease. This has been replicated over and over, across an astonishing range of species: yeast, worms, flies, mice, rats. Very few findings in all of biology are this consistent and this durable. So caloric restriction is the closest thing aging science has to a rock-solid law: eat meaningfully less, and lab animals age slower. The obvious question is why, and the answer connects back to everything we've covered. So why does eating less slow aging? Because it pulls the exact same biological levers that the longevity drugs are trying to mimic, which is a beautiful piece of unity in this field. When calories are scarce, your cells sense it. That master growth switch M2, from the rapamycin episode, quiets down. Insulin signaling drops. A fuel-sensing enzyme called AMPK, the same one metformin nudges, switches on. And critically, the cell ramps up autophagy, its internal recycling and cleanup program, chewing up damaged proteins and worn-out components and reusing them. In short, scarcity sends your body a message: this isn't the time to grow and reproduce, it's the time to hunker down, maintain, and repair. And that maintenance and repair state is, essentially, the anti-aging state. Rapamycin, metformin, and fasting are all, in a sense, different routes to the same destination, convincing your cells that food is scarce so they switch into repair mode. Now, constantly eating 30% less for your whole life is miserable and, frankly, almost nobody can sustain it. Enter the modern, more practical cousin: intermittent fasting and time-restricted eating. The idea is to get the benefits of scarcity by cycling, periods of eating and periods of not eating, rather than permanent restriction. Popular versions include eating only within an 8-hour window each day, or fasting for longer stretches occasionally. And there's real science here: fasting does reliably trigger that autophagy cleanup process, and it can improve metabolic markers like blood sugar and insulin sensitivity. But here's an honest nuance the influencers often gloss over: a good chunk of fasting's benefit may simply come from the fact that when you restrict your eating window, you tend to eat fewer total calories. In other words, some of the magic might just be plain old eating less, repackaged. The special metabolic effects beyond that are real but more modest than the hype suggests. So does this translate to humans? Here's the honest picture. The major human trial of caloric restriction, called Caloric, asked healthy people to cut 25% of their calories, and in practice they only managed about 12% over 2 years, because sustained restriction is genuinely hard. Even so, it improved their metabolic markers and reduced biomarkers of cellular senescence, which is encouraging. But, and this matters, humans on caloric restriction do not show the lifespan doubling that mice do. We're not going to live to 150 by eating less. And severe restriction carries real risks: muscle and bone loss, low energy, weakened immunity, disordered eating, and it's outright dangerous for some people. So the honest takeaway is that mild caloric moderation and sensible time-restricted eating are reasonable, evidence-supported tools, but extreme restriction is not clearly better for humans and can do harm. Don't starve yourself chasing mouse results. This is educational, not medical advice. Talk to a doctor before starting any fasting regimen.